Today I will discuss about Cramer's V Association. It has been explained manually and as well as by Python. Hello friends, good evening. I am Dr. Nazrul Islam, Associate Professor, Department of Geography, Kuchbehar Panchanan Burma University. Now we have to define Cramer's V Association and when to use it. Cramer's V is a statistical measure used to assess the strength and association between two categorical variables in a contingency table. It is an extension of Pearson's chi-square test and it provides a value between 0 and 1, where 0 indicates no association and 1 signifies a perfect association between the variables. Cramer's V is particularly useful for determining the association between two categorical variables with unequal contingency tables. As I have mentioned in my previous video that when the contingency tables are in equal number, then we use high association. On the other hand, if the contingency tables are unequal, that is 2 into 3 or 3 into 4, we use Cramer's V association. So consider a study examining the relationship between gender, that is male or female, and job satisfaction low, medium or high, and these observed data are tabulated here. All data are in categorical formation and we have 3 columns, low, medium and high, and 2 rows, that is male and female. We have to perform chi-square first to evaluate whether there is a statistical significant association between the two variables. For this we have several steps calculation for chi-square test. We assume number 1, we assumed null and alternative hypothesis as null hypothesis, that is H0 is the association between gender and job satisfaction is not significant. That means variables are independent. Alternative hypothesis, that is H1, is the association between gender and job satisfaction is significant. That means variables are dependent. Step 2, we assumed significance level, that is alpha, as 0.05. Step 3, degrees of freedom in chi-square test is number of rows minus 1 into number of rows minus 1, that is 2 minus 1 multiplied by 3 minus 1 equal to 2. Here in the step 4, we arrange the database in the following table like 1 1 1 2 1 3, and as I have mentioned earlier that 1 1 means row 1 column 1, 1 2 means row 1 column 2, 1 3 means row 1 column 3. On the other hand, for female, 2 1s means row 2 column 1, 2 2 means row 2 column 2, and 2 3 means row 2 column 3. This is the summation of R1 R2. This is the column total C1 C2 and C3. This is the end, that is total number of observation is 165. Step 5, now we have to find the expected count using the following formula. As you know, expected count for chi-square test is summation row multiplied by summation column divided by n. On the basis of this, we find out the expected counts. For low and males, that is 1 1, value is 15.91. Expected count for medium and males, that is 1 2 29.55. Expected count for high and males, that is 1 3, is also 29.55. Expected count for low and females 2 1, that is 19.09. Expected count for medium and females, that is 2 2, the value is 35.45. Expected count for high and females, that is 2 3, is also 35.45. Step 6 represents the worksheet for chi-square distribution, where we input the observed count and expected count in each row and column for further calculation. Here O minus E and O minus E whole square is also determined, and chi-square formula has been applied here for finding out the chi-square value. Here it is the summation of chi-square value, and we use the formula chi-square ij for determining the chi-square result. Here I represents rows and j represents columns. Therefore, the chi-square value is approximately 3.223, and we find here. Now step 7, with degrees of freedom 2 and alpha 0.05 for the 2 into 3 contingency table, the critical value or tabulated value is approximately 5.991. This has been find out from the chi-square table. Step 8 represents the condition of chi-square value for taking decision. If chi-square is greater than critical value or p less than alpha, we reject the null hypothesis, that is H0. If chi-square less than equal to critical value and p greater than equal to alpha, we fail to reject null hypothesis. Step 9, we have to comment on the result. Since the calculated chi-square value, that is 3.223, is less than the critical value, that is 5.991, the p-value is also 0.1995, which is more than the selected alpha, that is 0.05. We failed to reject the null hypothesis and concluded that association between gender and job satisfaction is not significant. Now we calculate Cramer's V to know the strength of the association between gender and job satisfaction for nominal variables, that is categorical data with unequal contingency table. This is the formula of V equal to root over chi-square divided by n minus k minus 1, where chi-square is the chi-statistic, n is the total number of observations, that is sample size, the sum of all frequencies in the table, 165 in this case. K is the minimum number of rows and columns in the contingency table, 2 rows and 3 columns. So we take here 2 as the minimum number. So after calculating the result, Cramer's V, we get the result 0.14. Thus, Cramer's V values ranges 0 to 1, with higher values indicating a stronger association, as we mentioned earlier. So the Cramer's V for this example is approximately 0.14, which indicates a very weak association between the gender and job satisfaction in this dataset. Therefore, based on the chi-square, we concluded that the association between the gender and job satisfaction is not statistically significant. This Cramer's V and chi-square test has been performed in Python code, and this is the result. This is the equivalent result that we have calculated manually in the previous slides. So this is the identical value, and this is the screenshot of chi-square and Cramer's V in pie chart. If you want to copy this code and put in the pie chart or anaconda, you can get the result. Thank you for watching my channel. Please do subscribe my channel for getting the new ideas in advanced statistics.